Okay, this is the second videos for chapter 8.1, 8.2 counting methods, permutation and combinations. So we're moving on to the topic for permutations. So there is a formula for that. This is how many objects and choose how many, and that will utilize what you just learned for the factorial. They use like the total object factorial over the total object subtract how many objects are chosen. So for this one, there are a few things you have to pay attention to. For permutations, make sure that is something that the order does matter. Okay, and then each objects are distinct. So there are different type of thing. Maybe you're choosing like president, vice president, or treasurer, or you're picking 3 prizes: first prize, second prize, third prize, etc. So not just picking 3. Alright, so and there is no repetitions. So earlier, like sometimes you can repeat all the numbers, etc. So for permutation, order matters. Each object is distinct, and also no repetitions. Okay, all right, so let's try some examples. Let's look at number 10. Number 10 say found a permutation of 10 objects picking 3, and the order does matter. So let's look at this. Number 10, we're going to have the order matter kind of give us that permutation, but they kind of told us too. So it's going to be P10 pick 3, right? And on your calculator it's a 10P3 like this. But we would like you to be able to do it by hand, so let's see if we can do that. So it's going to be 10 factorial, right? And then we need to do what here? 10 minus 3 factorial, so it's like 10 factorial. This is 7 factorial, right? So earlier we did that. It's not that bad. It's 10, 9, 8. We can stop at 7 factorial, right? And then we deal with that 7 factorial at the bottom. So it's just 10 times 9 times 8. So that together, use your calculator, is 720 ways. So actually, we kind of did that earlier with the no repeating stuff. Basically, you have 3 slots, and at the beginning you have 10 choices, right? And then after that, no repeating, so you only left with 10 choices. And then after that, you only have 8 choices, right? So together you have 720 ways. So the permutation, you can think of it as like that, but if the number is really huge, sometimes it will make sense to use the formula. Alright, so that's number 10. The answer is 720 ways. So let's look at number 11. Number 11 say there are 16 members in the organizations. So 16 is total, right? We need to choose a president, a vice president, 2 things. How many outcome would that be? So this time, for number 11, let me do it like that. Sorry. Alright, so number 11, we basically have 16 members, and then you're going to choose a president and 1 vice president, right? So I can see that the order kind of matter, and then they are distinct objects, And also there's no repeating, right? If I'm the president, I cannot also be the vice president, right? And president and vice president are not the same thing, and so the order kind of matter. There's no repeating. So we can say this is permutation. So some of the question may ask you, is it permutation or combinations, which we will talk in a minute. So this is the permutation problem. So basically we have 16 and we're going to choose 2, right? So the regular way is 16 factorial, 16 minus 2 factorial, right? So 16 minus 2 is 14 factorial. So 16, 15, and 14 factorial, that got cancelled. So just 16 times 15, right? What is 16 times 15? So it's going to have 240 ways to choose those 2. So if you understand this perfectly, you can also say I have 16 choices at the beginning, and then for the president's position. And after I pick a president, I only have 15 more members to choose from, right? So this is for the vice president. So together it's also 240 ways. So either way would be okay to calculate the answer for that. Hope that makes sense. You can actually use the calculator, and depending on if you have like a newer calculator and older calculator, this is how that works. The older type, you will go to mathematics. And then on top of here, the last one, PRB, is probability. So we will move to PRB. So number 4, you can see is the factorial. Earlier we did 5 factorial is 120, right? So if I quit out of this, I do 5, and then I go in math, probability, and choose 4, which is factorial, is 120, right? So it should be 120. You can use the calculator to check, but we want you to be able to do it by hand. Okay, and then if I was doing 16, choose 2 for the permutation, right? So my calculator is old, so I need to do 16 first, and then go to math, and then probability, permutation is 2, right? So I pick 2, it look like that, and then I choose the 2, enter, that's 240, that's what we just found, right? So the old type, you have to type the total number first, and then pick the permutation button from math and probability 2, and then you put in how many you're choosing from. So for the newer type, hopefully that's newer. Okay, so I would do math, and then again probability on top, and then that's 2, right? So it will have a space for you to put the first number, have a space for you to put the second number, and it's still 240. So you can use it to check your answer, but we want you to be able to do that by hand, okay? That's not too difficult. We will give you the formula though. Alright, so that's permutation. Let's look at the next topic. So they say if n objects in permutation are not all distinguishable, we use the following method. So some of the test question may look like the next one. They say how many different ways can the letter in the words of the following be arranged? So if I move this letter around, how many arrangement can I have? So the first word is guitar, the second word is Mississippi. So let's look at these together. What do we know about them? Number 11. Okay, so let's see. Sorry. This one is number 12. We are going to have how many ways can you arrange the letter in the word? First one is guitar. G-U-I-T-A-R. Okay, so I don't have anything repeating because I don't have anything repeating. No letter repeating. So I have 6 letters, which means 1, 2, 3, 4, 5, 6. So I have started with 6 different letters to choose from. If I pick one of them, now I only have 5 choices, right? And then 4, and then 3, 2, 1, like that. So I can just multiply them together. This will be basically 6 factorial, which is 720 different orders. Okay, so this is actually basic multiplication counting methods. Okay, so now if I look at the second word, which is Mississippi, how about Mississippi? M-I-S-S-I-S-S-I-P-P-I. Okay, this is kind of complicated, right? So how many letters? 2, 4, 6, 8, 10, 11. So we have totally 11 letters. Okay, so that would be 11 factorial, right? So 11, 10, 9, 8, etc. That many different order. But some of them are repeating, right? We have 1, 2, 3, 4 I's. So that would be 4 factorial. And then I have how many S? 1, 2, 3, 4 S. So that would be another 4 factorial. And then I have 2P. So 2P's. So that would be 2 factorial. So the way to calculate this is you're going to have 11 factorial to choose from, but then some of them are repeating, so you have to divide 4 factorial, and 2 factorial. So they're not distinct number, so letters, so like when it's repeating, even though you move them around, it's still kind of the same. So that would be, so the highest I can reduce is 4 factorial, right? And you cannot plug this to the calculator. So 11, 10, 9, 8, 7, 6, 5, 4 factorial, right? Let's make sure I did it right. 4, 5, 6, 7, 8, 9, 10, 11. And then we have 4, 3, 2, 1, and then I can do 1 4 factorial reducing it, and then this one would be 2 times 1, right? So I have 2 times 1 here, I have one of them here, I have one of them here. Okay, so I can reduce. The 4 factorial is gone. I can do 2 times 3 here, and 4 times 2 is 8, so 8 is gone, and then 3 times 3 is 9. So after you multiply all that on top, you should get 34,650 orders. So I think that's a good exam question. So if you have something like this, you need the total letter on top and then divided by the factorial of the repeating letters. Alright? You may have a test question like this. Be careful. Okay, so next question on your handout, we are moving on to combinations. So this is combinations. And this is the formula for combination. and it's the same as this. So like this is same with the permutation. Some of the book we put it like that, some of the book we put it like that, and your calculator look like this, right? So they're all correct and they're all the same thing. So combination is similar, it just have a slightly different calculation for that. The key things for this is combination still not still, this time order doesn't matter. Not matter, okay? And then you still have distinct objects. And then still there's no repetition, no repeating. So this time the main difference between combination and permutation is the order doesn't matter here. But the other stuff is the same. Okay, so the next two questions we want to know, are they permutations or are they combinations? So let's look at this. So some of your homework question may ask something like that. For number 13, is it permutation or combination? If you have 105 employees and you need to pick a 3-member committee, so this time it didn't say like one is president, one is vice president, one is treasurer, etc. They just say pick 3. So those people, the order doesn't really matter, right? So but if you already pick like Amy cannot be the second one, so it's not repeating, so it's still 3 distinct person, but you can pull 3 at a time. So the order doesn't matter. So because of that, this one, because order doesn't matter, so we're going to have what? This is a combination question. So we have from how many to choose from? We have 105 and we need to pick 3 of them. So number 13, this is for A part, this is a combination problem because order does not matter. You pick 3 people at a time, they don't have like specific jobs, etc. Okay, so this is combination. The B part, so we're going to do 105, combination is 3. I do it like what your calculator would do. So they say plug in this formula, so 105 factorial divided by, this is 105 minus 3 factorial, and then we also need a 3 factorial, right? So that would be 105 factorial, this is 102 factorial, 3 factorial, right? So we need to somehow reduce it. So this would equal to 105, 104, 103, and then 102 factorial. I can leave it like that, right? Because I have a 102 factorial at the bottom. And then 3 times 2 times 1 for the next part, right? So I can get rid of 102 factorial. And then 2 times 5 is 10, 2 times 2, okay. 3 times 1, 3 times 3 is 9, 3 times 5 is 15, right? So if we multiply these 3 numbers together, you should get like a really big number. 187 for 60 combinations. Because the order doesn't matter, so huge number. Are we okay? So that's number 13. One more question. Last one. Number 14. We have 105 employee, and the president, vice president, and the treasurer will be picked from the committee. So this time the order seems to matter, right? Because they actually have like a specific job for each of the 3 members. So number 14. I think this is permutation. because order matter. Okay, and what are we doing? 105 members. Okay, and then you will pick a president and vice president and the treasurer, right? Okay, so this is permutations, so 105p3, right? So permutation, we do what? It's easier just 105, 104, 103, right? The formula, let me do it one more time. This is going to be 105 factorial and then 105 minus 3 factorial, right? So this is 105 factorial, this is 102 factorial, right? So 105, 104, 103, 102 factorial divided by 102 factorial. So if you get rid of that, just multiply those three, and then we will have 112460 order. So it's a really big number. 112460 orders. Okay. So again, like if you know what you're doing, permutation basically mean you have 3 slots. This is the president, VP, and the treasurer, and you started with 105 member, right? So 105 choices times 104 choices times 103 choices. So it's doing the exact same thing. 105 times 104 times 103, right? So 112460 orders. So either way would be okay. And you can always check it with the calculator, depending on you have the newer one or the older one. The newer one, you just do math. This is probability, so move to the probability. Oops, sorry. Math, probability, and then I need to pick, this is permutation, so it's 2. We do what? 105 permutation with 3. Okay, so same number. And then earlier we did number 13. Number 13 was what? Number 13 was a combination. So when we did the combinations, if I check it with my calculators, again I did math, probability, numbers 3 is combination, is going to be 105 and then a 3 here. So earlier we got this number, looks correct. So that is how you do it on a calculator. And again, if it's the older one, you will do a number first, pick that button, and then the last number. So for this particular one, it was 105 combination of 3, 105. I need to go math, probability, 3 is combination, 3 enter is the same answer. Okay, all right. The very last part, sometimes students get confused. When do you use the counting method? When do you use permutation and combination? So you need to ask yourself, is there any kind of replacement? If yes, you can use like the 10 digit again and again and again. Then you just use the multiplication principle. If there's no replacement, if you pick like Amy as president, you cannot put Amy back to the group to pick for vice president. If there's no replacement, then you will ask yourself, does the order matter? If the order matter, it's permutation. If the order doesn't matter, it's combination. So I have a little table here. You may want to write that down to help yourself to decide. It's just multiply order number or permutation or combination, okay?